Hello class, welcome to lesson 10.5, which is all about the distance formula. By the end of this lesson, you should be able to use the distance formula to find the distance between 2 points on a coordinate plane, and you should be able to apply the distance formula to solve problems about figures on the coordinate plane. Excuse me. So let's talk first about what is our distance formula. You're going to use the distance formula when you have any 2 points or coordinates. So if you have a drawing on the coordinate plane, or if they just list coordinates in your problem, you can use the distance formula. So this is another thing that's very, very important for you to write down, very important for you to try to memorize, just like the Pythagorean theorem. The Pythagorean theorem and the distance formula are something you are going to use so very much in Algebra 1 and geometry, okay? So the better you learn this now, the easier those classes are going to be as you move forward with math, okay? So the distance formula is d equals the square root of the quantity of x2 minus x1 squared plus the quantity of y2 minus y1 squared, okay? So it's fairly similar to working with the Pythagorean theorem. If you think about it, it's kind of like your a squared and your b squared, and you are adding them together, and then instead of having a d squared, we got rid of that squared and we took the square root of both sides. So they are pretty similar to each other if that helps you memorize it, okay? So let's work with our distance formula. So remember, we have d equals the square root of, and then we take our x values and we subtract them before we square them. Then we add those to the difference between our y values squared. So if I look at my figure, I'm going to just say that my x1 value is going to be letter B. So this is going to be x1, y1, and x2, y2. If you did it the other way around, you would end up at the same answer. It's okay. If you wanted to treat this as x2, y2, and x1, y1, oops, that's a y, y1, you would end up with the same answer as what I'll get doing it the other way. It's just very important that you stay consistent, just like when we talked about slope, okay? So anyways, using my x2 value as being negative 2, I'm going to subtract 4 from it. And then my y2 is 1 minus 3 squared. So if I keep going, I have d equals the square root of negative 2 minus 4 gives me a negative 6. So I have a negative 6 squared. So that means I have a negative 6 times a negative 6. Or that gives me a positive 36 plus 1 minus 3 gives me that negative 2 squared. And remember, negative 2 is negative 2 in parentheses squared is negative 2 times negative 2, or positive 4. And I'm left with the square root of 40. Okay, so I ended up at the square root of 40, which is approximately, if I use a calculator, 6.3 units. Let's try doing it the other way and see if we truly do end up at the same answer. So I have d equals the square root of, we will do 4 minus a negative 2 squared plus 3 minus 1 squared. So we have 4 minus negative 2, that becomes 6 squared, or 36, plus 3 minus 1 is 2, 2 squared is 4, so I end up at the square root of 40. So you can see it doesn't matter which one you assign x1 and x2. 2 as long as you are consistent. Why don't you go ahead and try to find the distance between 5, -6, and 1, 2. Round to the nearest tenth if necessary. Hopefully you ended up at 8.9 units. If you have any questions about that, please be sure to ask a friend for some help. Rewind the video, look for some answers there, or ask myself. Let's look at our second example. We're talking about a map. And if we look at this map, we have the Department of Defense, the U.S. Capitol, and the Madison Building. We're told that 1 unit on the map represents 0.05 of a mile, or 5/100ths of a mile. We want to find the distance between the Madison Building at 3, -3, and the U.S. Capitol at 0, 0. So if I do D equals the square root of, if I say that the Madison Building is my x2 and y2, and I'm going to say that the U.S. Capitol is my x1, y1. So I have x2, which is 3 minus x1, 0, squared, plus my y2 is going to be that -3 minus 0, squared. So I have the square root of 3 minus 0 is just 3. 3 squared is 9. Plus -3 minus 0 is -3. -3 squared. Remember, that is -3 times -3. Don't say that is a -9. That is a positive 9. So I know that the distance is the square root of 18. And if I simplify the square root of 18, that's approximately 4.24264 units. But I want to know how far those two buildings are. So what I'm going to go back to is that 1 unit on the map is 5/100ths of a mile. So I'm going to take that 4.24264. I'm going to multiply that by 0.05 to find out how far that really is in miles. Because we don't care how many units it is. That means nothing to us. We don't measure in units. We measure in miles for maps typically. So that ends up multiplying out to be 0.21 miles. So that is my final answer. Why don't you go ahead and try to solve this problem about kicking a soccer ball? Hopefully you ended up at 10.2 yards. If you have any questions about that, please be sure to ask for some help. All right, and then the last thing before we move on to the last thing, let's do a quick summary of what we've talked about so far this chapter. We know the angles of a triangle. We have X, Y, and Z, 3 angles, triangle, 3. They all add up to 180 degrees. That's one very important thing for you to memorize. Another important thing for you to memorize is our Pythagorean theorem, our a squared plus b squared equals c squared. And the fact that if that happens, if that's true, it's a right triangle. And our distance formula is the last thing that you want to make sure you memorize for the upcoming test, okay? We'll add a little bit more in 10.6, but this is kind of a good summary of Chapter 10 so far. All right, example 3, we are going to talk about classifying triangle XYZ by its sides. Okay, so that, remember when we classify things by sides, that means it's either going to be equilateral, isosceles, or scalene. And in order to be able to tell, you have to look how many sides are the same length. And then we want to find its perimeter to the nearest tenth. So if I see a triangle, I know I have 3 sides. I have XY. In this case, I have XY, I have XZ, and I also have YZ. Okay, so I'm going to solve each of those. So XY equals, and then I need to start solving. So if I decide that I'm going to use this as my x2, y2, and x1, y1 in this instance. So my x2 gives me the -2 minus a -5 squared plus 4 minus 1 squared. So that is the square root of negative 2 minus negative 5 becomes negative 2 plus 5, or 3 squared, plus 4 minus 1 is 3, and then squared. So we have the square root of 18. 3 squared is 9. 9 plus 9 gives us the square root of 18. That is approximately 4.24. Let's try looking at xz. And xz, if I solve that one, I know, or I'm going to use these as, or negative 3 is going to be my x2, y2, and negative 5, 1 is going to be my x1, y1. So I start negative 3 minus a negative 5 squared plus negative 3 minus 1 squared. So I have the square root of negative 3 minus a negative 5 becomes negative 3 plus 5, or 2 squared, plus negative 3 minus 1 is negative 4, and negative 4 squared. So we have 2 squared, that gives me 4, plus 16. So that's the square root of 20, which is approximately 4.47 if I plug it into my calculator. And then the last side I want to do is the green side, which goes from y to z. And if I do that, let's see, what one do I want to use? I'm going to use negative 3 is my x2, y2 again, and y is going to be my x1, y1. So yz is the square root of negative 3 minus a negative 2 squared plus negative 3 minus 4 squared. So it's the same thing as negative 3 minus a negative 2 is negative 3 plus 2, or negative 1 squared plus negative 3 minus, plus. We have negative 3 minus 4 gives me negative 7 squared. So negative 1 squared just gives me 1 plus negative 7 squared is 49. So that is my square root of 50, which is approximately 7.07. Okay, so I found the 3 sides. Now I want to classify it by its sides. So equilateral means all 3 sides are the same. I don't have 3 equal sides, so I know it's not equilateral. Isosceles has 2 equal sides, and I don't have 2 equal sides, so I know it's not isosceles. Scaling has 3 different sides, so I know that's what type of triangle this is. So it's scaling. And if I want to find the perimeter, that means I add up the sides, the side measures. So I have 4.24 plus 4.47 plus 7.07. And if I add all of those together, I get 15.78, but it asked me to round to the nearest tenth, so 15.8 units would be my answer there. Why don't you go ahead and try to solve this last one on your own? Hopefully you determined that it was an isosceles triangle and the perimeter was 20.5 units. If you have questions about that, please be sure to reach out for some help. Have a fantastic day.